Hello and welcome to a special single bag episode of Mailbag. For the first time ever, I actually purchased a bunch of stuff from the same seller on AliExpress, so I thought I'd make a mailbag video with just that bag. At least, I think this is what this is. If not, well, I can always add some more, so let's open this. So there's a lot of stuff in here, so I want to make sure not to cut it. And yeah. So, nice assortment of stuff. Let's check them out one at a time. First thing up is this PCB ruler. As you can see, this one's just over 15 centimeters long, or just over 6 inches long, and black solder mask. Basically, it's used to, I don't know, check out the sizes of things. So these are the some resistor sizes, all the way from, let's see, 0603 all the way up to 5025, plus they have the different surface mount packages for crystals, typical like regulator stuff. They have some circuit symbols here, a couple footprints for ICs, wire gauge in American wire gauge, and they have trace widths here from 6 mil to 40 mil. That's mil, MIL, not mil like millimeter. They have a few footprints here. These are two BGAs. BGA's ball grid array, by the way. It's just these little sort of solder pads here, and the underneath of the IC has little balls that you put solder paste onto this and you reflow, and it solders like that. A couple more of these footprints, and then one PCB to ruler them all. I guess a nice attempt on some humor there. So this is pretty nice. This was $1.06, and I got this from AliExpress. Actually, everything you're going to see here is from AliExpress. So let's go on to the next one. Next we have these, and these are some LED matrices. These are red LEDs. They're actually pretty small. I think they're a couple mils. I think they're 3 mils a piece. These were 70 cents each, so each of these matrices were 70 cents. And I'm not quite sure how to use these, so it's going to be interesting to try to figure out how the heck to use them. I guess I'll make a dedicated video on that, but figuring out the pinouts and maybe doing a couple of rudimentary designs, and then eventually using something like an Arduino or a dedicated chip to actually drive these and get figures on them. You can get these in bigger segments where there's like 3 or 4 of these put together side by side by side, but I figured I'd get the raw ones, especially for 70 cents a pop. It'd be worth playing with. So I'm not sure if these are common anode or common cathode. I do know that they're available in different colors, and these ones, both of these, happen to be red. So I was just messing around with this LED matrix, and I just found some pins at random here on diode check that turn on that corner LED. And if I take off this black one and I just run it along the pins here, not sure if you'll be able to see that. There we go. See, some they light up. Just light up here. You see that? So if I hook this up to here, I get nothing. I hook this up to here. Oh, I got some here. Oh, not that one. This one. There we go. Got a different one to light up there. So yeah, I think this is going to be fun to try to figure out. So next up are these jumper leads. So this is 120 pieces in total of multicolored leads. I paid $3 for them, and what's cool about these is this set is male to male, so it has the male pin on both ends. This set is female to female, so this more like to put jumper leads in. This is more for breadboards, and this is male on one end, female on the other. And so these are to, let's say, connect a connector directly to a breadboard or whatever, stuff like that. And so these are pretty good to have on hand. $3 for all of it, and I'm always seem to be running out of test leads, so now I've got a whole bunch, and I don't have to worry about conserving colors or whatever. Pretty simple, nothing much to see here. If you've never seen these, they just sort of peel off like that, and you're left with just a single color, or you can keep them as a ribbon and use them for differentiating signals and keeping them tidy. Pretty cool, I recommend it. So this was $3 Canadian for all 120 pieces of these. And I do recommend getting the male to male, female to male, and female to female. It's always good to have a variety. Don't get them too long though, because then it's clutters everywhere. These are 20 centimeters, so they are a bit long for a lot of stuff, but I can always trim them down or cut them in half, or whatever. Cool. I had to zoom you right in for these next items. So these are actually two separate items just joined together. At least they're supposed to be. Yeah, they do snap off. There we go. These are two digital amplifiers. I guess Class D. I think Class D amplifiers mean that that they don't go from analog to digital anywhere inside there, or the whole conversion stays digital or something like that. So these are built on a single chip amplifier. I believe they're stereo, because I do see left and a right plus and minus out. They're based on the PAM 8403, and these things are absolutely tiny. I think one of these squares here are I think these are half-inch squares. So yeah, like 3/4 of an inch by 3/8 of an inch, maybe. I don't know. Oh, this is a half inch. That'd be more. So yeah, like almost 3/4 by 3/4. How much that is in metric? Well, I guess we can use this little ruler here. Let's see. Set that up where you can see. One thing I'm already not liking about this ruler is that the zero doesn't start right at the edge. I might sand that down so the zero is right at the edge. So 20, hold on a sec, 22 mils by 18, is that millimeters? Very, very small amplifiers, and these were 34 cents each. So I'm actually curious to see what kind of output we can get out of this, especially because it's stereo. It's 2 channels. Not much to see here, but interesting nonetheless. This next item required a zoom in also, because it is actually much smaller than I thought. Let me just open this up here. And if you watched Julian Eilit's channel, you probably would recognize this. This is a neopixel ring. So this is because I've actually never played with neopixels. I have RGB LEDs, but not the addressable ones. So these, you send out a digital signal, and there's a chip on board. Actually, you could probably see, it's probably that tiny little black spot there in the center. I'm not quite sure. Quite possibly, that does look like silicon. But this is a tiny little circle. Diameter roughly 40 millimeters, a little bit less, 38 mils maybe. So tiny little ring of addressable LEDs with the pads on the back. And I'm actually excited to get these working, because I think the Arduino requires a few tricks to get the signaling fast enough for these things to deal with. Also, it'd be nice if I got a hang of this and was able to put a whole bunch of tiny little AT-tiny chips on the back here, and kind of put these all around the house, sort of like how Julian Eilit did. Basically, he looked like he had fun, so I think I'd want to give it a go too. This one was a bit more expensive than I usually pay for something this size, but neopixels are pretty pricey. This was $1.85 Canadian, and doesn't seem like a lot, but again, this thing is just absolutely tiny. At least it gives me something to work with, something to play with. So next up is this kit of trimmer pots. Now, again, I paid a bit more for this, but I felt it was important that it came in this little kit. Julian Eilit uses these two, and I have typically used pots, but I have just the massive kind. This kind is much easier for dealing with breadboard, considering they're so tiny. And I wanted an assortment, so not only do I have an assortment now, but they're also in their own little container here. I do have a problem with organization, so this should help with that. I can pull a couple out here and read off some values, because as you can see there should be 10 different values. So this one is a 502, so I believe that is 50 ohms plus 2 zeros, that's 5,000 ohms, so 5K pot. Let's see, I have to bring them closer to me because I'm pretty far away for that small writing. So that's a 105, so it's 10 with 5 zeros. I think that's 100K. And so yeah, I should have the kind of the whole gambit here. Julian Eilert uses these for like his 555 timers, and I've always used resistor dividers, so having this instead of 2 individual resistors seems like it would be a lot more convenient. So yeah, I think that should be nice. I think you're going to see these in upcoming videos a lot more often. This cost me $4.25 Canadian to buy, but these little boxes are quite pricey. I think they're $1.66 at the moment. I do have some coming, a bunch of boxes like this, because I do want to keep some components in these little guys. And the final item from this mega pack are these LEDs. There's 100 LEDs in here. I paid $1.25. Now you're going to think that's a bit much for 100 LEDs, but here's the deal. I have a ton of white LEDs. I have a few red ones, but what I don't have is an assortment. So there are a bunch of LEDs here. There should be 10 different colors, and I guess 10 of each to make 100. And so this should be useful when I need a specific color. I don't have to, let's say, color a white one. I can just grab the color I want, and if I do need more, if let's say I use up all the green ones, well then I know I can order 100 of the green ones because I know I'm going to use them enough. At the moment, just having white is okay for testing purposes, but I think for making videos, it's better to have differentiating colors sometimes. So yeah, let's try to light a couple of them. So one thing I've noticed about these LEDs is that the labeling is terrible. This one, I don't know if you can see, but that kind of says PIC? PK? Maybe that's pink? Just thought of that now. So what I did is I put some tape on the backside, just regular green painter's tape, and I think I'm going to light these one at a time, and I'm going to write down on them their forward voltage and what they are. So I'm just going to set up here. So I think these should be pink. Take your guesses as to what they are. So let's see, I'm going to put this into diode check. I'm going to try to prop this up so you guys can see. There we go. So it's in diode check mode. The long leg should be the positive. And I don't know if you can see, but that is definitely pink. So forward voltage 2.58. So we'll go pink. Then 2.58. Forward voltage is less important because you just set a dropper resistor and it kind of does its own thing, but it's good to know, I suppose. But at least now I'll know that it's a pink LED instead of whatever the heck the labeling was. So that's good. Let's go on to this one. Like, what's that? It's like line dot. I'll tell you, the only ones that I'll know what color they are is going to be the white ones, because they have a piece of phosphor which is supposed to glow, because there's no such thing as a white LED. All the white LEDs you see are blue and they have a phosphor coating. This is very dull, actually. I don't know if you can see that, but that's either orange or yellow. I think I'm going to go with yellow. Whoops, forgot to get the forward voltage. So we'll go yellow 1.896. I should have actually wrote these down. I'll go 1.89. Should have wrote it down before putting the label on, but that's okay. You'll take this off. These little clip leads are amazing. Everyone should have a set. I think it only cost me $1 or something. Alright, so we have pink and yellow so far. Let's try this one. YG or YY? I don't really know what that means. Okay, YG or YY? Let's see what color you are. That is green. Man, that one's dim too. 1.887. Maybe I'll try a Sharpie. I was trying to avoid using Sharpie because I thought it'd be too thick. 1.887, so let's go 1.8. Let's round it up, 1.89. Green. It does write better. Okay, that is dim. That is extremely dim. I think these things are cheap. That's fine. Let's try this one. R. I think that's red. I'm hoping it's red. If it's red, it has a 1.7 or so volt drop. Usually the long leads are positive, just as a by the way. Let's see. Yes, that is red. Seeing if you can see that. 1.794. So red. 1.79 volts. Good. This one, O, orange, I believe. Yeah, definitely orange. So go ORG. I think I'll know. I don't think I'll think that's Orgrimmar or anything. So 1.84. That's good. Flip these off. These. Oh, this one wiped away. I don't really know what color they were supposed to be. Oh, these are white. I'll show you if the camera can pick it up. I don't know if you can see. Does it look yellow to you? There's nothing lit here. It's not plugged in. So that yellow is the phosphor, and the more sort of white-ish the yellow is, so the lighter the color of the yellow, usually the cooler the temperature of the white. Yeah, that is white here. Yeah, I don't know if you can catch this again. So 2.584. So that is 2.58 volts. So yeah, that's the phosphor. So basically, if you were to open these and scrape the phosphor off, it would just be a blue color on the inside. It's a specific blue that excites the phosphor. This one, just a squiggly line for the color. I'm not too hopeful. Okay, let's check this out. This one has shorter leads, actually. Very odd. I really thank the people who took the time to make these. Oh, this is white also, but this one's a cool white. I should have checked the phosphor. Yeah, there's phosphor in there. So that is a cool white. So the other one is white. This one is cool white. I suppose this is like quote unquote pure white, and the other one is warm white. So I'll put a white W and a C white. I actually forgot to get the forward voltage of that, so I'm actually going to pause, grab the forward voltage, and then continue. So the cool white was 2.59 volts, and now we're moving on. So this one has a B, I believe that is blue. So it should have the same forward voltage as the white ones, because the white ones are just blue LEDs, after all, with a phosphor coating that gets excited. So here we go, we're going to check down the barrel there. Nope, no phosphor. Oh, somehow I'm in ohms now? Interesting. There we go. Wow, that's a piercing blue. I find camera sensors tend to be very sensitive to blue colors. So I find the blue, I'm not sure, I'll have to check during the edit, but I'm not sure, this blue should be quite a bit harsher than the other colors. So 2.625, so that's blue. And then 2.6. Okay. Even my terrible marking method with my terrible handwriting is better than what it was before in terms of recognizing what they are. That's good. 2 more to go. BW? PW? No idea. No phosphor, so the W doesn't mean white. Let's try this. Oh. It's like purple? Oh, maybe it's PU. Okay, so purple. 2.88. Okay. It's pretty nice. It's an interesting color, purple LEDs. Not sure what I'm going to use them for, but interesting nonetheless. And last is G. We had green. I'm not sure if this pack comes with 2 greens. I don't know. I don't see any phosphor. It's not white. G. Oh yeah, that's like a deep green. What was the other one? One was YY. Like yellow green? Maybe YG? Yellow green? Not sure. We'll call that deep green. Whoops, I need the forward voltage. So 2.3. Let's call it deep green. 2.3. Okay. And there we go. all 10 accounted for. Pretty sweet. So all in all, I think this is a pretty successful haul. I think these are all things that pretty much all electronics hobbyists should have. So you need jumper leads, you need these pots, especially the ones in the breadboard pitch. These nerd rulers, always good, especially when you're ordering resistors online and you're trying to figure out what size they're going to be. You can actually use this as a quick reference, which is good. LEDs of all different colors, yeah, we should keep those in stock. Amplifiers, maybe not so much, but if you're interested in that kind of stuff, like I am, maybe that's good for you. And neopixels, because, well, everyone's got to play with those. Thanks for watching.